Imagine this, you are walking to a class and your friend suddenly says, "Don't forget your umbrella." You look up, the sky is blue, the sun is shining, birds are literally vibing. Why would you need an umbrella? But 2 hours later it pours. Your friend was on a fortune teller, they just noticed the tiny sign you ignored. The sticky air, the quick breeze, maybe the weather app you forgot to check. That's exactly what probability does for AI. It does not know the future, it just reads the signs, the tiny patterns hidden in millions of data points and make a smart guess. And if you watched my last video, you already know probability is one of AI's 3 big math superpowers, and today we are zooming in deeper into the math of maybes. Here's the thing, most people get wrong about probability. They think it is just about coin and dice, 50% head, 50% tail. Simple, right? But real life is way messier. When a doctor sees your blood test, they don't say you are sick or you are healthy. They say based on these numbers, there is a 70% chance of this condition. That's probability, taking messy data and turning it into meaningful maybe. AI works the same way. It takes keywords, the pixel in a photo, the words in a message, your taps and swipes on a website, and turns them into something mathematicians call random variables. Basically, numbers that could take different values depending on chance. Some are discrete like spam or not spam, click or not click, stayed or skipped. Others are continuous like video brightness, watch time, scrolling speed. And just like weather forecasts use different models, rainfall versus temperature versus wind, AI use different probability distributions to make sense of its world. A normal core when things cluster around an average, a portion when rare event matters like earthquake or server crashes. Each distribution is like different lens AI use to study the future. Every decision you make leave a tiny footprint, a number. AI collect these footprints like clues from crime scene. Some clues are toggles, yes, no, click, not click, stayed, left early. Others come in smooth range, your watch time, scrolling speed, how long you hover over a post. Once AI know what kind of clues it's dealing with, probability give it a special tool to interpret them. Those tools are called distributions, and each distribution is like a different lens for making sense of the chaos. Imagine you are guarding a digital village and 10 strangers knock on the gate. Each one has a fixed chance of being a threat. The question is, how many threats will you face today? That's uncertainty, but with structure, it is what the binomial distribution captures. It tells us the likelihood of a certain number of success out of fixed number of tries, and success can mean anything: an email marked as spam, a user tapping skip, a sensor detecting motion. Whenever decisions are countable and each event has the same chance, the binomial distribution has AI predict how often something will happen. Not exactly, but realistically. Reality has a favorite shape. Most things gather around the middle: your sleep hour, exam score, video watch time, even how fast you walk. The natural clustering from the normal distribution, the famous bell curve. AI loves this shape because thousands of people believe slightly differently but not widely differently. The normal distribution whispers, here's what typical looks like. It keeps prediction calm and grounded. Prediction isn't about a single movement, it is about what repeats. Expectation is simply the average outcome you had get if you could replay the word millions times. Like flipping a coin thousands times, you don't expect exactly 500 head, but you do expect something around 500. That around is expectation. For AI, expectation is the anchor. It stops randomness from throwing the system of balance. Human choices are really random. We are pattern wrapped in emotions. If someone listens to sad song at 2 a.m., that's pretty good chance they will click on breakup playlist too. That isn't magic, that's correlation. Correlation tells AI when this moves, that tends to moves too. Correlation just measures how strongly they move together. This relationships helps AI make predictions not by knowing you personally, but by following patterns across millions of choices. All these ideas, binomial, normal, expectation, correlation, form AI quiet playbook for guessing the future, not perfectly but usefully. Probability turns randomness into structure and structure into understanding. How does all this connect back to AI? Simple. Probability is not just a chapter in math book, it's the engine behind how AI model think. Take something classic like Naïve Bayes. It doesn't understand your message, it doesn't read your email like a human, it just assigns probabilities to different possibilities. This word usually appears in spam, these patterns usually appears in harmless emails, then it picks the outcome with the highest probability. That's it. Super simple, super powerful. And it is not just for spam filter. Every recommendation, every prediction, every you might like this movement is probability distribution quietly working under the hood. Whether it is recognizing your voice, spotting object in a photo, or guessing which video you will binge next, AI is constantly playing with this giant number game. Whether the goal isn't to be certain, just to be more right than wrong. So the next time YouTube recommend you guilty pleasure teaser video, don't blame the algorithm. It is not spying on you, it is not reading your mind, it's just math. Probability whispering the future, kind of like that friend who knew it would rain even when the sky was clear. And if you want to keep following this trail of AI secret ingredient, how it predicts, learns, or sometimes messes up, you already know the drill. Hit the subscribe button or just let the algorithm gamble that you will come back anyway.